Okay, let's give you guys some practice. This time you're given the normal vector, you're given this normal vector, and you're told that the plane passes through this one particular point, this one particular point. So come up with the equation for this plane. Remember that this point here is floating in the middle of nowhere. So your origin, so this is your grid. Your origin is here. So this point here is floating in the middle of nowhere. Well, come up with the equation for this plane. So press pause and have a go. Okay, so to do this, we would set up our general point. P. This point is x, y, z, and then we demand that this vector here. We demand that the dot product of this vector. Sorry, the dot product of this vector here and this vector here to be equal to 0. That's how we would describe a plane, because a plane is perpendicular to this normal vector. So we would demand that this general point here, we would demand the vector to be the dot product, the dot product of this vector, the dot product of this vector and this vector to be 0. So our next step is to figure out this vector here. So currently, remember, we are this point here is floating in the middle of nowhere. So we need to obtain this vector here from this point to the general point here. So this vector would be, so you're currently in the x direction, you're currently at negative. So in the x direction, let's say in 3D space, this is the origin here. So this is y, this is y, this is x, and straight up would be z. But in the x direction, you are currently at -3. You're currently at -3, and you want to get to the point x. So you would need to go +3. You would need to move 3 steps in the positive direction, and then get to your general point x. So this vector in the x direction would be x plus 3, because currently you are at -3, so you're right here. So in order to get to your general point x, you would need to go 3 in the positive direction and then x amount, so it would be x plus 3. So to get from here to this point here in the x direction, you would need to move x plus 3. Okay, now hang on. So now we need to get from here 0 to y. So in the y direction, it would be this. Hang on, in the y direction, let me just clear this. Set up this point again. Bear with me. X, y, z, and then so we are currently here. We need to obtain this vector here. In the y direction, we are currently at 0 in the y direction. So we are currently at 0. We need to get to the general point y. So we need to just move y amount. So this vector here will be y amount, and then we are currently in the z direction. We are currently at 7. So in the z direction, we are currently at 7, and we need to get to the general point of z. So it's really, we are currently here. We just need to travel this amount here. Well, this amount here would be z take away 7. So this amount here would be z take away 7. So this vector here would be z take away 7. So the vector that takes us from our point here to our general point would be this, and this. Okay, so that would be, so hang on. So our general point here is x, y, z. So the vector that takes us from here to here is given by this. It's given by this. Okay, and then in order to describe our plane, we need to demand that the dot product of the normal vector and our vector to be 0. So we demand that this vector here to our general point, this vector here, the dot product of this vector and this vector to be 0. So we demand this. We would demand this. So remember, the normal vector is given by this. So the normal vector 5, 2, -1. Normally we would write vectors like this, but I'm deciding it to write it like this. So here it's, hang on, let's go back here. So it's 5, 2, -1. So it's 5, 2, -1, and we're taking the dot product. And this vector here would be the vector that travels from here to our general point x, y, z is given by this, because look, this is this, this is this, and this is this. So the dot product would be this times this times this, plus this times this times this, and then plus this times this times this. So now I'll multiply this out, blah blah. That will then take you to here, and then tidy this up. Single number, throw them on the other side. That will then give you this. So this is our equation of the plane. Notice that this is the normal vector here. So you can always extract the normal vector. That's this vector here. You can always extract a normal vector by looking at the coefficients. This one here, this one here, this one here, and so on. So this is our equation. Okay.